Hello, my fierce fifth graders. This is Mrs. Rowley with this week's topic of discussion. So, I have new pictures from my weekend. I was just so lucky enough to get outside this weekend to have a bonfire with my husband. This is the fire that we had, and this is us enjoying it. And it was just a great weekend. I hope you had as much fun outside as we did because the sun was out and it was warm and it was lovely, and it is supposed to be a great week weather-wise. So, I hope you're ready for the week, and I hope you're ready for some good, hard, challenging math. Let's look at last week's topic of discussion first. This would be a good opportunity for your teachers to pass back your old slips as well as the new slips. So as we go over the work, you can see your work and compare it to what I'm going to show you on the screen. All right. The vocabulary last week, the definition that I gave you was the point from which all points in a circle are equally distant. I can tell you that as a fifth grader, I had no concept of this at all. I didn't really know much about circles other than they were round until I hit high school. But if you had said center, which most kids did, I did have one student, I think it was Kylie Robin, who said middle, and I counted middle. I accepted middle as an answer. She meant the middle of the circle, the center of the circle. That is absolutely right. So if you think about a circle, and you think about its center, it's a really important quality to know that that little dot is the same distance from the middle to the edge of the circle, from there to there to there and to there. All of those arrows are the same length. What an important attribute of circles to know that um, they're these are called this is called a radius. They're all the same, and so you can do a lot of interesting math with circles if you know that. And even though I only put 4 radii on the circle, there are an infinite amount of radii which extend from the center to the edge of the circle, and they are all the same length because that little center is the same distance um, from all points on the circle, and the points on the circle would lie on the circumference. So a fascinating tidbit about circles, and I hope you are able to retain that because you can just do some fantastic problem solving if you know that all radii in a circle are equidistant or have the same length. So fantastic. All right, the question last week. Sung Hee empties her piggy bank and she finds that she has 200 quarters, 150 dimes, and 300 pennies. How much money does she have? Explain. I found this question interesting because most fifth grade students saw this as a multiplication problem. When I looked at it and I went to solve it, because I solve it before I look at your answers, um, I I actually used both multiplication and division to solve it. And I noticed that Emma Kluke in Mrs. Blank's class, she also used division to solve it too, which I thought was interesting. So let's see how one of many ways to solve it. Let's look at one way. So I did some thinking about what I know about these denominations. So I know that um, every 4 quarters equals a dollar. When I have 4 quarters, I have $1. And I know that dollars are pretty easy to count. So I want to try to make dollars when I can. All right, and I know that there are 4 quarters in a dollar. So Mrs. Hallisey's group will recognize this a lot because we worked on it. I want to take those 200 quarters and I want to split them into equal groups of 4, and I want to find out how many of those equal groups of 4 I have. That will tell me how many dollars I have. Because I'm working with zeros, I'm going to do some mental math, and I'm going to think about, if 20 were divided by 4, that would give me 5. That's a basic multiplication fact. 20 divided, that's a multiplication fact. 4 multiplied by 5 is 20. Therefore, 20 divided by 4 is 5. So that's, again, a basic fact. And so then I know that 200 divided by 4 will be 50. I've added a 0 to the 2 to the 20, and I've added a 0 to the 5. So I know that I have $50 in quarters, and I'm just going to make a note of that off to the side. And so for the pennies, I used division. And oddly enough, when I counted up my dimes, I used multiplication. And I truly don't know why I swapped back and forth. But you'll see what I'm talking about. I started off the same. I know that every 10 dimes equals $1. So I want to split my 150 into equal groups of 10. And so when I split my 150 up, I actually took 10 and I put them into groups to get to 150. So I know 10 groups of 10 is 100. That was helpful for me, using my tens to get to where I want to go. And I know that 5 groups of 10 is 50. So I know that I have 15 groups of 10, and that's going to give me $15. And so I'm going to make note of that on the side as well. And so now I just have to deal with my pennies, which nobody had trouble dealing with. So every 100 pennies is $1, and I have 1 to 300 pennies, so I'll have 1 to $3. And then I make note of that on the side as well. And then I'm just going to add up all my money. 50 plus 15 plus 3 will give me 68. So Sung-hee has $68 total. So there were a handful of kids that got $68. But this is what I saw a lot of, and I found it interesting. What happened was the kids, some kids who saw this as a multiplication problem went through and multiplied, and they did their standard algorithm, which is fine, and they came up with correct answers. 200 times 25 is 5,000, and 150 times 10 is 1,500, and 300 times 1 is 300. That was no problem. You guys got that hands down. And then you took those 3 products and you added them together. So 5,000 and 1,500 and 300 will give you 6,800. And then you stopped there and you interpreted that 6,800 as your answer. And you told me she has 6,800. And what happened there was you viewed your change as if it were a whole. Instead of 25 cents, you multiplied like it was $25 essentially. And so that kind of threw you off. When you're dealing with change, you're not dealing with wholes, but percentages of wholes. So your quarters are 25% or 25 hundredths of a dollar, and dimes are 10, well, I say 10%, but these are in decimal form. 10 hundredths of a dollar, and pennies are 1/100th of a dollar. So it's important to know that even though multiplying was a good strategy and it would have worked, because you multiplied wholes and not parts of wholes, or you multiplied the wholes instead of the change, your answer was way bigger than it should be. I want you to notice that 25 cents and 10 cents and 1 cent have a decimal that is moved 2 places to the left of your number. Like if you have the number 25, it would have a decimal to the right of the 5, and if you moved that 2 places to the left, you'd have 0.25. If you had taken your 6,800 and thought about the decimal to the right of the last 0 and you'd moved it in 2 places to the left, you would have had $68. You would have counted for that decimal. So, but I want you to know the multiplying was great. Your algorithms were slick, so good job with those. You just didn't move your decimal, or you didn't account for the fact that you didn't have wholes, you had only percents of wholes. So it's all right. Nice job. Nice job thinking it through, and nice work with your arithmetic. It was great to see. All right, let's look at this week's stuff. Your ticket this week should look like this. Go ahead and put your name on it. Please don't forget your name. I keep track of the people who are answering my questions and how many points that they're getting. So if you don't put your name on it, I don't put you down for points because I don't know who to give them to. So put your name. Put your name on it. Oh, wait. Okay. All right. Vocabulary word for this week means figures that have the same size and shape. Don't put the word same. The word same is in the definition, so it won't be the vocabulary word. Figures that have the same size and shape. There's a special geometry word for that. Same size and shape. What is that called? I'll be super duper impressed if you guys get this one. It's a tough one. It's a high school geometry term, no doubt. Figures that have the same size and shape. You can't ask your teacher, but I wonder what other resources you could use. You can always use each other. Talk to each other about it. See what you come up with. When you think you know, write your answer on the vocabulary side of your answer ticket. All right. Brian has a model collection of cars, trains, and fire engines. He has 28 cars. The number of fire engines is 2 times the number of trains. He has 68 models in all. How many of each type of model does he have? This is a great question, and it's going to take you some time to work through it because it's a multi-step problem. Put on your thinking caps. Brian has a model collection of cars, trains, and fire engines. He has 28 cars. The number of fire engines is 2 times the number of trains. He has 68 models in all. How many of each type of model does he have? This is tough. Work with a friend. Look at strategies that are happening within your groups, right? Ask a friend, see what they're doing, generate some ideas on how you can get this done. This is not an easy word problem this week, and it's not supposed to be. You guys are smart, and we have worked on modeling word problems like this. Show me how you get your answer by drawing a picture, writing words, or giving me a diagram. So once you have your vocabulary word, once you have the answer to this problem and you've shown me how you got your answer, and you've discussed with a friend your strategies and your vocab ideas. Remember, this is topic of discussion. You're supposed to be discussing. Hand your ticket into your teacher. She'll hand it in to me, and I'll get it back to you. All right, this has been Mrs. Rowley with this week's topic of discussion.